Hey everybody, welcome to the very first video lecture for anatomy and physiology. I know you all are super excited, yay we get to do video notes. What I'm trying to do with these video notes is try to do very short, concise notes for you to be able to watch the videos, take notes from, to be able to open up some free time in class for us to be able to do some more fun things. Because let's be honest, nobody really enjoys notes all that much. You might enjoy some of them, especially if you're like me. I loved school and I could do a little bit of notes. But if you start getting to 45 minutes worth of notes, we just, as humans, especially in today, we do not have the attention span to do notes for 45 minutes at a time. So what I try to do with these video lectures is keep them less than 15 minutes long. Sometimes there might end up being 2 or 3 video lectures that you'll need to watch, but each video will be less than 15 minutes long for you to be able to carve out some time, be able to watch these, and even if you're gone for a day, maybe you are sick, maybe you have football, volleyball, golf, track, whatever it might be, you're able to watch these videos whenever you have the chance, and that way you can keep yourself caught up in class. Today is our first video lesson. Typically, there will be a quiz over each video lesson. Usually they're going to be anywhere between 3 to 10 questions, but there is no quiz over this one, over this video lecture. One other thing is that I do not require you to take notes. I know back in Science 9, your freshman year, or Earth Science, whatever you ended up taking, you had your own notebooks that the other teachers would help you kind of keep yourself organized. I, however, do not make you take notes. I put that responsibility on you. That way I can focus on some other things to help you become scientists in this classroom. I will, however, encourage you to take written notes. A lot of people like to take typed notes, especially with the Chromebooks that we have here at the high school. But typically, written notes, handwritten notes, are retained by students about 30% more. So it's just scientific that taking written notes helps you out a lot more than anything else. But again, I'm not going to make you take notes. That is just my suggestion. So let's get rolling. Video lecture 1 here is kind of a broad overview of anatomy and physiology. That's what A and P means there. So there's 2 really big ideas that we see here in anatomy and physiology. We're going to talk about both of them here as we get rolling. But first I want to cover what is A&P. Now you may have surmised by now this is A&P stands for anatomy and physiology. So anatomy is going to be the study of human structures. And we're going to go more in depth into what I mean by structures here in a second, because that is our first big idea. But with anatomy, you can study microscopic anatomy or you can study gross anatomy. These are 2 kind of subfields that you can go in if you're an anatomist. Microscopic anatomy, obviously you're going to be studying structures that are seen under a microscope. If you're going to be studying gross anatomy, you're going to be looking at things large enough for the human eye to see, just the naked eye. So these are large muscle groups, large limbs, different parts of the body that you can see, that you can feel, that you can manipulate and easily isolate from one another. 2 ways that anatomy can be studied: regional and systemic. Regional, you think a region of the country is a certain area of the country. Regional anatomy is going to study specific regions. So if you are planning on being if you want to go into orthopedic surgery and you want to specialize in Tommy John surgery, you're probably going to study regional anatomy of the arm. Tommy John surgery is typically done in baseball players when they have an injury of the UCL that runs along here. So you're going to study a lot of the structures of the elbow and really of the entire arm. Systemic anatomy studies the body system. So these are things like your skeletal system, your muscular system, your nervous system, and that's what we're going to be doing in this class, because it tends to break things down easier and kind of puts things into neat little units, neat little sections for us to progress through during this year. Physiology then is the study of chemistry in the physics of functions of the structures. So physiology deals a lot with the structures of the human body, but it focuses on what they do. What is their function? So there's a key difference between anatomy and physiology there. This class is going to be a survey, kind of a broad overview of both the anatomy and physiology of the human body. So to study the human body, we use both observations and inferences. This isn't one of our big ideas, but I just wanted to talk about them because it ties easily into our first big idea. And an observation is something that you can see, something that you notice. Typically, it's something that you can sense with one of your senses. You can see it, you can smell it, you can taste it, you can hear it, although I'd highly suggest not tasting it in a human anatomy course here. But an observation is just something that you notice. An inference, then, you may remember from an English class, inference is a conclusion that you draw based on your available data. Now, inferences aren't going to be concrete, and inferences can change when data changes. We saw a lot of this with different things with COVID-19 and the vaccines. We made a lot of inferences based on observations we were seeing in this virus. And so based on what we are inferring about this virus, how can we best develop a vaccine? How can we best develop treatments? And then we got new data, and then sometimes those inferences changed. Sometimes those conclusions had to change because something was wrong with our inference. And so our first big idea in anatomy and physiology is structure versus function. You can see this all throughout the state standards. Usually at the beginning of every day, I have the state standards that we cover in class listed. And every single section of our standards covers structure and function. So we've already talked about structure being the anatomy of the human body, or structure in anatomy being in human anatomy here. You can talk about various structures outside of life here, but it's going to be the physical makeup of an object. What does it look like, basically? So one example of this is you can have, if you take a look in long bones, things that you have in your upper arm here, in your femur, you'll see on the outside of long bones, there is a very solid, very thick and dense layer of bone. That would be a structure that you can notice, that you can sense in long bones. Functions, then, we can infer functions based on what we see. So remember, function deals with the physiology of an object. So if we look at long bones and we see that solid dense layer, that is our observation of a structure. We can then infer a function. Well, if that layer of bone is really solid and really dense, it probably does a really good job of supporting and protecting bone. And that's exactly what it does. There are other sections of long bones that their structure is actually very matrix-like. A lot of spaces, a lot of holes and everything like that. You would probably infer a different function for that because of that different structure. So other examples we see across scientific disciplines, if you find a fossil, you find some sort of bone, paleontologists do a really good job, and it's the main part of their job, is trying to infer a function for this bone, for this fossil, whatever they found. They're trying to infer its function based on the little data that they have available. So if they find this long bone and they see that it has a solid, dense layer, they can infer that that bone was probably very good for support, for protection, for weight bearing. That takes us to some things in the human body that we'll take a look at. There are countless number of structures. I mean, you can go all the way from gross structures all the way to microscopic structures. So there's really no way to put a number on that. But each structure has a very specific function in the human body. So each function, each structure are very perfectly matched from one another, or at least they used to be perfectly matched to one another. For example, we'll talk about the appendix, how it is really no longer used in humans, but at one point, its structure was perfect for its function. And so we'll see this as we go through, but one key thing that I want you to look at as we go through this entire course, we'll talk about a lot of different structures, we'll talk a lot about different functions, a lot of anatomy and physiology. It's the whole point of the course. But one way to really train yourself and really to kind of help yourself review material is if you saw this structure, what would you infer its function to be? Because the human body is absolutely incredible. Lots and lots of these structures are going to be just absolutely perfect for the function that they carry out. Our last big idea that we have in anatomy and physiology deals with feedback systems. And I wanted to touch on these because feedback systems don't get enough love in a high school anatomy and physiology course, mainly because we run out of time to talk about the endocrine system, which deals a lot with feedback systems. Now, feedback systems, you can have two types. You can have positive feedback systems or negative feedback systems. Negative feedback systems are, by and large, the most common that we see in the human body. What happens is when the human body exits homeostasis, so think your temperature gets too low, your temperature gets too hot, blood sugar levels too low, too high, whatever it might be. Remember, homeostasis is that stable internal environment, that healthy level. When your body exits homeostasis, negative feedback systems are going to return them back to homeostasis. So an example, if you get too cold, your body temperature is too low, your muscles are going to cause you to shiver, they're going to generate heat, that is going to return your body back to homeostasis. Let's say that your blood sugar levels get too high, your insulin is going to be released by the pancreas, that causes blood to move into your cells and out of your blood, and as a result your blood sugar goes from too high back to normal. So these are all examples of negative feedback systems. Positive feedback systems, on the other hand, are extremely rare. And really off the top of my head, I can only think of two examples that exist in the human body. But they are still important. Really, their job is to push the body further away from homeostasis. So what happens is your body exits homeostasis, and then positive feedback systems kick in to push it even further beyond homeostasis. A great example of this is when you have an infection and you have a fever. You have this infection that causes your body temperature to get a little high. So say you start pushing 99, 100 degrees, 100.4 I think is the actual clinical level of hitting a fever. When you hit that, when you have a fever, your body continually makes you warmer and warmer and warmer. And that's why you really feel so miserable when you have this infection. But what happens, that fever is raising your body temperature to kill the infection, because whatever is inside you can only exist at 98, 99 degrees Fahrenheit. It can't exist at 100, 101, 102. So what happens, your body temperature raises to 101, 102, kills the infection, and now you no longer have an infection, and negative feedback systems can set back in to return your body back to normal. Now, those can go awry. Positive feedback systems can go awry because you're going to 101, 102 degrees to kill that infection, but once you hit 104, we really have a hard time living at that temperature. So it's a very, very fine detail and very monitored that these systems have to be. So that is all we have for our first video lecture. If you have any questions, make sure that you post those on the updates tab. If you're a student and you notice that somebody had a question that was posted on the updates tab, feel free to answer those. I may not always be at my computer or able to answer those right away. Maybe you can help out your peer to be able to answer those questions. Again, there's no quiz over this video lecture. Typically there will be short quizzes. So I'm looking forward to the rest of this year, and hopefully you can get used to and maybe even enjoy these video lectures.